Hello everybody, this is Shivakumar. Today we are going to discuss about nuclei. So nuclei is the plural of the nucleus. Okay, right. So we know that everything in the universe is made up of matter. Okay, so let us take this watch. This watch is also a matter, right? So this matter is consists of so many atoms, right? So matter consists of the atoms, right? We'll write the atom here, atom. So here let us take this duster. This duster is also made up of the atoms, right? So we'll see now what is there inside of the atom. So atom consists of electrons, protons and neutrons. So an atom consists of electrons, protons and neutrons. Let us write electrons, protons and neutrons. Okay. So let us draw the diagram of the atom. Generally, we think that the atom is in the shape of the sphere. So we think that 90% of the atoms we think that we are going to have it is in the shape called spherical shape. Okay, so here I would like to take a sphere. Okay, so in that I would like to take a nucleus. Okay, so this is the nucleus, 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 right? So and here this is my electron. Okay, so here you see the atom consists of electrons, protons and neutrons. So here we are having electrons, and where the protons and neutrons are in the nucleus. Protons and neutrons are in the nucleus, right? So this electron is revolving around the nucleus. Okay. So here let us take the radius of the sphere, radius of the atom. Radius of atom. So the radius of this atom is about 10 to the power minus 10 meters. So the radius of this sphere, so this is atom and this is nucleus. Okay, so the radius of this atom is equals to 10 to the power minus 10 meters. And let us take the radius of nucleus. Radius of nucleus, right? So the radius of the nucleus is about 10 to the power minus 15 meters. 10 to the power minus 15 meters. Okay, let us see the what volume of this atom to the volume of the nucleus. So generally we consider the atom in the shape of the sphere, right? So volume of atom to volume of nucleus, right? So generally we take the shape of the atom and the shape of the nucleus is spherical shape. So let us take 4 by 3 pi r cube. So here r, I am taking r is my radius of the atom, and small r is for radius of nucleus. Okay, so the volume of the sphere is 4 by 3 pi r cube. So for that reason I wrote 4 by 3 pi r cube here. And the volume of nucleus is also having the spherical shape, and it does not have a sharp edges. It does not have the sharp edges. Okay, so this will be equals to 4 by 3 pi small r cube. Okay, right. So here you see this 4 by 3 pi and this 4 by 3 pi is going to get cancelled. So the remaining is r by r whole cube. Okay, so here generally we take that the radius of the atom, r is the radius of the atom, right? So radius of the atom is equals to 10 to the power minus 10 meter, right? I would like to write here 10 power minus 10, and the radius of the nucleus is about to the 10 to the power minus 15, right? So here by this we can tell that the radius, volume of atom to volume of nucleus. So here you see, if 10, here you have to take power 3, right? Okay, this 10 power minus 15 move to upside, then here we are going to get that 10 power 5 whole power 3. That will be equals to 10 power 15. 10 power 15 meters. So here what happens? Volume, no matters. No meters here. Okay. So volume of atom is equals to 10 power 15 times of the volume of the nucleus. NuCleus. Okay. So here what happens? The volume of atom is equals to 10 power 15 times of nucleus. That means let us think that if the classroom is my atom, okay, the classroom is my atom, then the volume of the nucleus will be about the volume of this tip of this pen. Okay, so if you think that this is my nucleus, then this is my nucleus volume, then you have to take this much of, and that means 10 power 15 times. 10 power 15 times of this nucleus volume has to be taken. So here what happened? The volume of atom is very large than the volume of nucleus. Okay, right. Next you see the nucleus, the structure of the nucleus. So here what happens? Nucleus is consists of, okay, so nucleus is consists of protons and neutrons. Electron is just revolving. Okay, let us write the electron details first. Let us write electron. Okay, so electron is a subatomic particle, right? So it is subatomic particle or subparticle of atom, and the charge of the electron, the value, it is having some value. So the charge of the electron will be equals to 1.6 into 10 to the power minus 19 coulombs, and mass of the electron will be equals to 9.1 into 10 to the power minus 31 kg. Okay, and it is the fundamental, electron is the fundamental quantity. Electron is fundamental quantity. So what is fundamental quantity? By this we are going to discuss about anything. So here what happens? Electron cannot be split into any others. Okay, so electron is taken as the fundamental quantity, right? So the charge of this electron is minus 1.6 into 10 to the power minus 19 coulombs. This minus means here electron is negatively charged. So we need to take electron is negative charge. Negative charge. So here you see the electron is represented by like this, E minus. Electron is represented by E minus. So here what happens? Here we are having electron is a subparticle of the atom, and the charge of this electron is equals to minus 1.6 into 10 to the power minus 19 coulombs, and mass of electron is equals to 9.1 into 10 to the power minus 31 kg, and this is the fundamental quantity, and here it is a negatively charged. Okay, negatively charged. Next we see the proton. Okay, so proton. So proton is also a subparticle of the atom. Okay, subparticle of atom. And here we are having the charge of electron, and here the charge of proton. Charge of proton, that will be equals to plus 1.6 into 10 to the power minus 19 coulombs. Here you see, here we are having the plus charge. plus 1.6 into 10 to the power minus 19. Here we are having minus 1.6 into 10 to the power minus 19 coulombs for electron, and for proton we are having plus. So that means we can tell that it is a positively charged. Positive charge. Proton is a positive charge. And here you see mass of electron that is equals to 9.1 into 10 to the power minus 31 kg. Now we will see mass of proton. So the mass of proton will be equals to 1.6726 into 10 to the power minus 27 kg. Mass of proton is equals to 1.6726 into 10 to the power minus 27 kg. And next here fundamental quantity. So is proton fundamental quantity? No. Why? Why? Because proton can be split into quarks. Quarks. Q-U-A-R-K-S. Just write Q-U-A-R-K-S. Quarks. So the proton can be split. So for that reason, we can tell that the proton is not a fundamental quantity. It can be split into the quarks. Then we can say the quark is a fundamental quantity, right? Okay. Next we will see neutron. N-E-U-T-R-O-N. Okay. So neutron is represented like this. Okay. And proton can be represented like this. Right. So P means proton. 1, 1. That means, okay, we will discuss later. And neutron is represented like this. And N, and here we need to take 1. Okay? Right. Next we will see the neutron. So here what happens? Neutron is a subparticle of the atom. Right? It consists in the atom. So for that reason we can write the neutron is a subparticle of the atom. Subparticle. Subparticle of atom. And here the charge of neutron. So what is the charge of the neutron? Charge of neutron is neutral. There is no charge. No charge. It is a neutral. It is neutral. Right. So neutron having the charge of no charge. Okay. Next, the mass of the neutron. So mass of neutron is represented by Mn. Okay. M means mass, N means neutron. Here you see M means mass, P means proton. Here you see mass, electron. Okay. So the mass and neutron here we are having. Okay. So the mass of neutron is equals to 1.6746 into 10 to the power minus 27 kg. Okay, so the mass of neutron is equals to 1.6746 into 10 to the power minus 27 kg. And here you see, here we are having negatively charged, and here we are having positive charge, and here we are having no charge. That means neutral. It does not have any charge. So it is a neutral. So is it a fundamental quantity? No. Why? Why? Because neutron can also be split into quarks. Okay, so neutron can also be split. So it is not a fundamental quantity. See, let us observe the mass of proton. Here we are having mass of proton is equal to 1.6726 into 10 to the power minus 27 kg. And here you see the mass of neutron is equal to 1.6746 into 10 to the power minus 27. So here you see, here we are having 4 and here we are having 2. Okay, so it is very small change. So for that reason, mostly we will take mass of neutron is similar to mass of proton. So mostly we will take the mass of neutron is similar to mass of proton. But mass of neutron is greater than the mass of proton. Okay, so generally we take like this. Why? Because it is having very small change. So for that reason, mass of neutron is similar to mass of proton. We are going to take, but mass of neutron is more than the mass of proton. Okay, so let us see. Here we are having mass of electron. So mass of electron is equal to 9.1 into 10 to the power minus 31. That means very less as compared to the mass of neutron or mass of proton. So here what happens? Mass of electron is very less than mass of proton, or mass of electron is very less than mass of neutron. So if you write in the order, first you write the mass of electron is less than mass of proton is less than mass of neutron. Okay, in some books also it will be there like mass of electron is less than mass of proton is equals to mass of neutron. Okay, it will be there like this also. Okay, next here you see mass of electron is very less than mass of neutron, right? So how much? So the mass of electron, let us take mass of electron. Mass of proton is equals to 1836 times of mass of electron. Okay, so mass of proton is 1836 times of mass of electron. That means we have to understand that how much big the mass of proton. So here what happens? We have discussed that atom consists of electrons, protons and neutrons, and nucleus consists of proton and neutron, and electron is revolving around the nucleus, and electron is the negatively charged and proton is positively charged. So here what happens? The mass of the atom is concentrated. On the nucleus. Okay. So this, and next we have discussed about the volume of atom to the volume of nucleus and how much big the volume of the atom as compared to the volume of nucleus, and we have discussed about the electron, proton and neutron, and we have discussed about the masses of them. Okay, now we'll see representation of element. Representation of element. Okay, so first we'll see, let us take an element of X. Okay, here we are having A and here we are having Z, or else in some books it also be like this, here A and here Z. Okay, so what is this A? A indicates, and what is this Z indicates? So A is that the mass number of the element. Okay, so here we are taking the element X, that means any element. Okay, so the element X mass number is A, and here we are in Z. So what is Z? Z is atomic number. Okay, so here I would like to write A is mass number, that means atomic mass number, or we can also directly write mass number, and Z is atomic number. Okay, so here we are having A, Z, X. So let us take an element, carbon element. So carbon element has C612. Okay, so here what happens? In mass number, we are going to have the number of neutrons plus number of protons. So mass number is having number of neutrons plus number of protons. And in atomic number, we are going to have the number of protons. So how many number of protons were there in that element is represented by Z, and what is the mass number is represented by A. Okay, so here we are having C12,6. Okay, so C is our carbon. So carbon is an element, right? So here what happens? Here we are having A. A is how much? A is mass number. Mass number means here we are having 12. So A is 12. And Z is atomic number. Atomic number is 6. So then what happens here? Number of protons here will be 6. Number of protons is 6. And here number of protons plus number of neutrons are 12. So if I want the number of neutrons, then number of neutrons is equals to A minus Z. That is equals to the number of neutrons. So here you see the number of neutrons is that the mass number minus of atomic number. Then here we are going to get the number of neutrons. Okay, right. Next, you'll see here we are having this atomic number. Sorry, mass number. So mass number is 12. That means number of protons and number of neutrons in an element. We are going to take. Okay. So here we have taken the 12. 12 is number of protons and number of neutrons. Right. This is number of neutrons. Number of neutrons. Right. So here you see C612 is there. So let us take helium. So He 4 and 2. Right. So here what happens? N. So number of protons are 2. Number of neutrons is also 4 minus 2. That is also equals to 2. So here what happens? Here Z and A. X Z. So is this Z is always less than A? That means mass number. So let us consider some examples of some O16 8, Li6 3. Okay, and next B 5 10. So is A always greater than Z? No. Why? Why? Because let us take hydrogen atom. So hydrogen atom is having H1 1. Right. So here what happens? Here we are having only one number of proton here. Only having the proton. Okay. So here what happens? This A is equals to Z in the case of hydrogen. So here what happens? The A is always not greater than Z. Okay. Next we will see atomic mass unit. Okay. So atomic mass. Let us write AMU. So the full form of AMU is atomic mass unit. Okay. Right. So atomic mass unit is that the mass of one atom. Mass of one atom. Mass of one atom in the element. In the element. Okay. So mass of one atom in the element is called one atomic mass unit. Okay. So we will take the mass of one atom, right? So in mass we are going to have number of protons and number of neutrons and number of electrons. So let us take n number of neutrons and mass. Here we are taking mass, right? So for that reason we have to take the mass of neutron plus n number of protons and n mass of the proton plus n number of electrons m number of electrons. Okay, so here what happens? The mass of this electron is very less than the mass of the proton. So for that reason we are neglecting this. We are neglecting mass of electron. Why? Because mass of electron is very less than the mass of proton. So for that reason we are neglecting. Okay. Next, we know that mass of proton is similar to mass of neutron, or mass of neutron is equal to mass of proton, right? So here we are having mass of neutron and here we are having mass of proton. So I would like to take mass of proton here. Okay. So here n number of neutrons plus number of protons. Taking MP is my count. Okay, so mass of proton taking count. Okay, so we know that here Mn plus Mp, n number of neutrons plus number of protons is that we are going to have this, right, mass number. So the mass number here we are having A, and mass of proton is atomic mass unit. So mass of proton is how much? Mass of proton is that 1.67 into 10 to the power minus 27 kg, right? So one atomic mass unit is equals to A means mass number into 1.67 into 10 to the power minus 27 kg. Okay, so this value also equals to A into 931.5 mega electron volts. So 1 AMU is equals to 931.5 mega electron volts. This A is the mass number of that element. Okay. This A, right? So this is A. A is atomic mass unit. So atomic mass unit here you can write this one, right? So atomic mass unit is A times A means mass number into 931.5 mega electron volts. And here atomic mass unit is equals to A into 1.67 into 10 to the power minus 27 kg. So here generally we take A here also. Why? Because A is multiplied. So atomic mass, right? Atomic mass. Right. So generally we take the mass of proton is 1 AMU, that is equals to 1.67 into 10 to the power minus 27 kg. So this is our mass of proton, that is also equals to 1 AMU is equals to 1.67 into 10 to the power minus 27 kg. Okay, so here we are having atomic mass unit. So atomic mass into the unit, that was the unit is equals to 1.67 into 10 to the power minus 27, right? So here also we are having a number of atoms per there, right? A number of atomic mass there. So for that reason, A into 931.5 mega electron volts, we need to write like that. So let us take here He4 and 2. So here what happens? Here we are having number of electrons. Number of protons. How many number of protons and how many number of neutrons were there here? So number of protons, that will be equals to, here we are having Z. So Z is equals to 2. And number of neutrons is equals to A minus Z, that is also equals to 4 minus 2. Right? Let us take here we are having 6 He 5 and 2. So here what happens? Number of protons are 2 and number of neutrons are equals to 5 minus 2, that is equals to 3. So here you see, here we are having helium 4 2 and here we are having helium 5 2 is there. So those are called isotopes. I will explain about this. Alright. Next, isotopes. Right. So isotopes. In isotopes, we are going to have number of protons are same, but number of neutrons are different. So in a nucleus, we are going to have number of protons. Number of protons are same and number of neutrons are changing. So in nuclei, let us write in the nuclei. In NuClide nuclei, the number of protons are same and number of neutrons are different. Right? So the number of in a nuclei, the number of protons are same and the number of neutrons are different. So there the chemical properties are similar, but the nuclear properties are going to be changed for the isotopes. Okay? So the chemical properties are same. Chemical properties are same for isotopes, and the nuclear properties nuclear properties are different. Are different. DIFF I wrote. DIFF ERAT I will write. Okay, right. Okay, so in isotopes, here we are going to have, here we have seen that He24 and He5 we have seen. So I would like to take 2 and 3, and here also I would like to take He4 and 2, and here also I would like to take He5 and 2. So here what happens? These are the isotopes of helium. So let us write H11, H12, H13. Okay, so these are the isotopes of the hydrogen. So this is called hydrogen, and this is called deuterium, and this is called tritium. This is called tritium. Okay, so the names of the isotopes I am just writing here. Okay, so here what happens? The number of protons are similar. See here we are having the number of protons of 1, 1, 1, and here number of protons 2, 2, 2 for helium, and for 1 is for hydrogen. So here what happens? Here the number of protons are not changing. That means the Z value is not changing. Z value is not changing. That means same. Z value is not changing. That means the same. But here A value is changing. A value is changing. So Z means what? Z means the atomic number. Atomic number. And A means mass number. Mass number. So mass number means what happens? In that we are going to have number of protons and number of neutrons, right? Okay, right. We'll discuss now. Now we'll see isobars. Okay? Isobars. So in isobars we are going to have same mass number. Same mass number. Mass number. So mass number is denoted by 8 and different DIFFERENT. Different atomic number. Atomic number. Okay, so here let us take some examples of C14, 6, N14, 7. Here you see, here we know that X is A here and Z here, right? So here what happens? Same mass number. Mass number means A has to be same. That means here we are having 14 and here also we are having the 14. So same mass number is there here and different atomic numbers. So here atomic number is Z. So atomic number here is 6 and here is 7. So here what happening? The different atomic numbers but the same mass number is there here for isobars. If any element like this, then we can tell those are the isobars. Okay, next we will see isotones. Isotones. So in that we are going to have same number of neutrons, and different number of protons. Different number of protons. Okay, next here the examples let us take O. Here we are going to get 6 and here we are going to get 17. N 7, 17 and F 19, 9. So here you see, here we are having this is 6, 7, 9. So here what happens? The atomic number and mass number are different. Okay, but here number of neutrons are same. Okay, so here A and Z both are different, right? Both are different. but A minus Z is same. So here let us see, here we are having A and Z, A minus Z. Okay, for oxygen here we are having A is equals to 6, Z is 16, Z is equals to 6, and 16 minus 6 is 10, and next here for nitrogen here we are having 17, A is 17, and Z is 7, and here we are going to get 17 minus 7 is 10, and here we are having 19 as my mass number, and atomic number is 9, so 19 minus 9 is 10. Okay, so here what happens? The number of neutrons are same. Number of neutrons are same. So when the number of neutrons are same, but the different number of protons are called isotones. So to represent these three in a table, let us take a table. So this is isotopes and isobars and isotones. Okay, so let us take this is A, Z, A minus Z. Okay, so in isotopes, here what happens? The Z value is same, right? In isobars, A value is same, right? In isotones, A minus Z is same. Right? So remaining all those are different. Okay, to write this. The structure of nucleus. Structure of nucleus. N-U-C-L-E-U-S. So the structure of nucleus is that generally we consider the spherical shape. The spherical shape having no boundaries. That is was observed by the Rutherford. Okay, so he given that estimated structure of the nucleus is that the spherical shape, right, and having no boundaries. Okay, right. Next we will see the radius of the nucleus. Right. So Rutherford observed in his experiments and he estimated the estimated volume of the nucleus is proportional to the mass number. So the estimated volume is proportional to the mass number. Okay, right. So volume is denoted by V and mass number is denoted by A. So volume of sphere is equals to 4 by 3 pi r cube. So 4 by 3 pi r cube is proportional to A. Okay, so here we are having R and A, right? So here the R is here I would like to take this R is equals to R naught A 1 by 3. Here you see, here 4 by 3 pi is constant, right? And to remove this proportionality constant, I am taking R naught here. So for that reason, what happens here? I would like to take the cube root of this, okay, and then cube root of this. Then we are going to get that R value is equals to R naught A 1 by 3, right? So this R naught value, this is the R naught value will be similar to 1.2 into 10 to the power minus 15 meters. So the radius of nucleus is about 1.2 into 10 to the power minus 15 meters. Okay, next we will see the density of the nucleus. NuCleus. So we know that the density formula. So density is mass by volume. So density is represented by rho. So density is mass by volume. Right? So mass. So here we are having the mass, right? So one atomic mass unit, that will be equals to AMU. So AMU is what? That is equals to 1.67 into 10 to the power minus 27 kg, right? So the substitute in that, and volume will be equals to 4 by 3 pi r cube, right? So here what happens? This density will be equals to A times AMU. AMU is equals to 1.67 into 10 to the power minus 27 kg and 4 by 3 pi r cube. So here we are having r, right? This r we have to substitute there. So then what happens? This value will be equals to r naught. So here we are having r naught, right? So r naught value we have to take 1.2 into 10 to the power minus 15 whole cube and into here we are having a 1 by 3. So a 1 by 3 has to be multiplied by, sorry, a 1 by 3 has to be multiplied by 3 times. So for that reason we are going to get a here. So this a and this a will get cancelled, right? So the remaining thing here we are going to 4 by 3 pi and 1.67 into 10 to the power minus 27, and all these are the values. So by taking all these values we are going to get the density of the nucleus will be equals to 2.3 into 10 to the power 17. So it's about the 2.3 into 10 to the power 17 kg per meter cube. So the density, here we are having the density of the nucleus. The density of the nucleus is equals to 2.3 into 10 to the power 17 kg per meter cube. Okay, so here density is independent of mass number and the atomic number. Density is independent of mass number and atomic number. Okay, so density is not going to be depend upon the mass number and the atomic number. So here what happens? Density is same for all the elements, all the nucleus. Here we are taking the nucleus, right? So for the reason we have to take the nucleus. So density of the any atom nucleus is same. That is equals to 2.3 into 10 to the power 17 kg per meter cube. Okay, let us take the density of water. What is the density of water? Density of water is equals to 1000 kg per meter cube. So density of water is about 1000 kg per meter cube. Here, if you compare the density of water to the density of the nucleus, I would like to write nucleus. Okay, so here what happens? The density of water is about the 1000 kg per meter cube. But here we are having the density of nucleus is about the 10 to the power 7 kg per meter cube. So let us write the density of nucleus to the density of water. Okay, and NuCl. Okay, I will write it again. Okay, right. So density of nucleus by density of water. So the density of nucleus is about the order of 10 to the power 17, and the density of the water is about the order of 10 power 3. Okay, so this will be 10 power 3. So this will be equals to density of nucleus is equals to 10 power 14 times of density of water. Okay, see, the density of nucleus is 10 power 14 times of the density of the water. So by this we can understand how thick the density of the nucleus is there. Okay.